Okay, so in this video we are going to discuss some more types of triangles, and one of them is called 45 90 45 degree triangle. What that means is, let's say if this is a triangle A B C, let me change the sharpness of the pen a little bit. Okay, then if and this is a 90-degree angle, so that one of them angle is 90, other one is 45, another one is 45, so that is called a 45 90 45 degree triangle. So in this triangle, because these two angles are same, so that means these two sides are same, and you can think if this is A, then this is also A, and this would be, by Pythagorean theorem, this should be, as you know that Pythagorean theorem is, this is, if this is C, then C square equals to this square plus this square. That means A square plus A square, which that lead to root 2A. So the sides of this triangle is A, and root 2A. Now from there you can easily find out the area. Area is half times height, which is, for this triangle the height is A, which is perpendicular to the base, which is again A, so which is A square by 2. Let me write it a little bit neatly. A square by 2. So that's about 45 degree, 90 degree, 45 degree. Now the second one is a triangle which is 30, 60, 90. So I think I have got, so let's say if this is 30, this is 60, and this is 90. Now why are we discussing these particular triangles? Only reason is because these triangles have a certain specific properties because of the ratios or their angles. So for example, there is not such properties or not such special properties for other combination of angles. So for this one, 30, 60, 90, if we combine two such triangles, 30, 60 and 90, so let's now try to figure out what could be the formula associated with this. So let's say if, since in this triangle, if you see, this is 60 degree, this is 60 degree, this is 60 degree, so this is isosceles, so I'm sorry, equilateral. So one of the properties of equilateral triangle is if you draw a let me get the pen again. So if you draw a perpendicular from the opposite, okay, I'm having a little problem with the pen. Okay, let me straighten it out. Okay, okay. So let me write first A, B, C. So if you draw a perpendicular, or if you draw the height from A to the opposite side, then it will touch in the middle. So it will touch in the middle. So that what that means is that if this is A, then this is also A, and since this is an equilateral triangle, so this is 2A and this is 2A. So if you apply the Pythagorean theorem on triangle, let's put it now later here. If you apply, if you look at ADB, and if you apply Pythagorean theorem, because this is a 90 degree, so then we'll get A square plus, let's say this is H square equal to 2A, which is 2A square, which is 4A square. So that means h square equal to 4a square minus a square equal to 3a square. So then h equal to root 3a. So this is one of the properties of a 30 degree, 60 degree, 90 degree angle, where you have the sides are a and root 3a. So where this is 60, this is 30. Now, and this is 90. Now, if you remember, we in our first video on the triangle we discussed that if angle A greater than angle B greater than angle C, then the sides A greater than sides B greater than sides side C. Sorry, these are sides. I draw them as angle. Okay, let me cut it down. So A greater than B greater than C. So if you apply this formula, or if you can see how this holds true for this one, because this is 90 degrees, so this is 2a. So this is 2a. 2a is greater than root 3a, which is opposite angle to 60 degree, and you see 60 degree is less than 90 degree, and this root 3a is even more than this side, which is opposite to angle 30 degree, which is even less. So just because, so let me write down here 90 greater than 60 greater than 30, where we have a which is 2a greater than root 3a greater than a. So we'll probably discuss some more concepts in one more lesson, and then we'll start solving problems on triangles.